All right, here we go for part 3, folks. Example 4, we've got a couple of thought clouds. There's the homework cloud coming up. The biggest rectangle problem we're going to save for the warm-up for the next video, so I'm not even going to discuss it. But this is an interesting one. Find the distance from this point to this curve, which is an interesting problem. If I got going, it's nice to find a diagram, right? Well, um, real quick, what would this sketch look like? I'd have a parabola move down 10, right? Something like that, where there's 10 minus 10. 7, negative 12 is down here somewhere. Let's exaggerate. Oh, 7, negative 12 is going to be down here somewhere, right? Negative 12, say here. And I'm going to erase this just so I can see the distance. Say, well, hang on, Restall. What are you talking about? There's an infinite number of distances to this curve, right? Well, usually we talk about the shortest distance, right? The shortest distance is like if this is land and this is the drowning man, the drowning person, and where would they swim? Well, they would swim the shortest distance, which is actually a perpendicular distance, actually. It's actually a perpendicular distance. But we can try and find the minimum value for D here, this D. Okay, so what's the required? The required is the minimum distance. And I have another one of these distance problems, right? This is, in my analysis, I'm just thinking about, I want to minimize the distance between this point and this curve, right? So this is good old grade 10, this thing, and I got variables all over the place, don't I? Right? I got 4 variables. Well, let's substitute in. Well, what do we got? We got one of the values is 7, right? X1 is 7, and Y1 is negative 12. Well, what's this value? What's this point right here? That point is the point, let's call it A, for the input A. Then if that's A, X is A, the output is A squared minus 10. We've pulled this trick before, haven't we? We've pulled this trick before. So then our X2 is A, and our Y2 is A squared minus 10. And then now, in my analysis brainstorming stage, it's not so bad. It's not so bad, is it? So I'm going to do something here as well. I'm going to do something crazy in just a second. First of all, let's substitute in. So this is A minus 7 squared plus Y2 is A squared minus 10 minus negative 12. Watch your signs there. It's a little crazy. See what I'm going to do here? Because this ended up, whoops, last example, this was pretty awful. Like in all this stuff, it was pretty awful. I'm going to try and avoid that this time. I'm going to do something crazy and square both sides. Then collect up the like terms in there. And then, well, what do I got? I got a implicitly defined function, right? Because it's not, this was explicit. This is implicitly defined. Defined. Some good writing there, Astal. Okay, and why is this so much better? I'll show you in a second, because now I'm going to take the derivative, and I'm going to set d prime equals 0. So watch this. So this is an implicitly defined function. It's a chain rule, so it's 2d and then d prime, right? Take the 2 comes down in front, write down the inside thing, and then the derivative of the inside thing is d prime. And then here, I'm taking the derivative with respect to derivative with respect to a in this case. And so then I'd have the 2 comes down, a minus 7, derivative of the inside thing is just 1. Here, derivative of the outside thing is 2, and then a inside thing stays put, then the derivative of the inside thing. And then what happens? Well, this becomes 0. And then I'm left with a not so bad, it's not great, but not so bad formula, plus 4a cubed. See, 2a times 2 is 4 times, that's a cubed, plus 8a. Collect some like terms. And unfortunately, guess what? For the first time in calculus, we're going to need to remember our factor theorem and try and find, right? Remember your factor theorem? If I call this thing f at a, I want to find a value of a that makes that 0, and then I can factor it. So f at, well, notice these numbers are nice, right? So f at 1 equals 0. So that means a minus 1 is a factor. And then I've got 4a cubed plus 0a squared, placeholder there because there's no a squared term. Ooh, boy. This is hard math. It's not that bad. It's great review. Great review of your function stuff because you've forgotten it, haven't you? 4a squared minus 4a, subtract, I get 14a, and that's going to work out just like I knew it was going to work out. So I get, this becomes, star becomes 0 equals a minus 1 times 4a squared plus 4a plus 14. Suppose I could have taken a factor of 2 out of there. That might have made my life a little bit easier. I see it in there now. So one of the solutions here is a equals 1. This doesn't actually factor, so I need to use the formula. A equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Phew. And I get my two solutions are, well, whatever, doesn't matter. And what do I get? Oh, what happens is underneath the root, because kind of surprising that I'd get 3 solutions because it looks like there's going to be one solution. Should be one solution. And there is actually, because this is underneath the root is less than 0. Remember, if you're using the quad formula on your calculator, you got to check for that, because these are what are called complex roots. That's less than 0. No real roots here. And so just the one solution, a equals 1. I substitute back in to my distance formula when a equals 1. D equals bing, bing, bing through this formula. Bing, bing, bing is about 7.8 units, whatever it happens to be, centimeters or whatever. Okay? Phew, what a good example. An even better example is this one here, but I'm gonna leave that one alone. Maybe we'll just assign that one as a bonus. If you would like to try this extra question and you're successful in answering it, There's probably one similar to this in the text, not quite, but it is a distance one. You go right ahead and you can try that for bonus. Okay, so that's it for optimization day 2-ish.